We've covered terminals, so let's now go on to component soldering onto a circuit board. What we're going to watch is the technique for soldering an axial lead component to a single-sided board. Here we're using a resistor. Cleaning is the first step. It's done with a rubberized abrasive stick, which gets off all the heavy oxides from the lead surfaces. The pads are also cleaned with the abrasive stick. Any oil or grease should be removed with solvent before the abrasive and then again afterwards. For bending the leads, a component forming tool or pliers will be used. It's adjusted to span the distance between the two holes and makes it easy to properly form the leads. After bending, the leads are wiped with solvent to remove oil or grease left from your fingers. The component leads are inserted through the board from the base side, and the fit is perfect. For a straight-through lead termination, the lead is cut at a length equal to the lead wire diameter. For a clinched lead termination, the leads are first semi-clinched, then cut to a length equal to the pad diameter. Then the lead is pressed flat in the direction of the track, positioning it along the center line. The process is repeated until all resistors are mounted in place. Now we'll watch the soldering of the leads. Notice that the iron touches the joint first, coming in from one side, while the solder is brought in from the other. The tip is in contact with the lead, since this is the principal thermal mass in the joint. It's done with a light touch, so that no pressure is applied to the pad. The solder is painted on, and then removed before the iron is removed. The iron is always swept over the end of the lead and removed to ensure that solder covers the end of the lead. Here you see the result, with all the characteristics of a preferred joint. First, there's a correct amount of solder and good wetting action. The surface is smooth and well feathered out to the edge. There are no pits or holes in it, and no evidence of flux once the joint is cleaned after soldering. The appearance of the surface is bright and shiny. With a clinched lead, the fillet should look like this, slightly concave and showing the shape of the underlying wire. The workpiece indicator here is the length of the solder flow along the conductor. An excessively long flow indicates too long a dwell time. With the straight-through leads, the preferred fillet looks like this. Again, the slight concavity and smooth, shiny surface. Joints like these are unacceptable because they have too little solder. As a result, the fillets are too small. Here, the fillets are too big. There is too much solder. Here are some other types of unacceptable joints. This is the rosin joint. Too little heat was applied, and there is still solidified flux between the wire and the terminal. Sometimes it may appear on the solder surface itself. This is a cold joint. When heat is withdrawn too soon, the solder doesn't feather out. This joint shows the other main characteristic of cold joints, a surface that looks frosty and granulated. Another unacceptable joint is this disturbed joint. It's also frosty and granulated, but here the cause has been movement during solder solidification. This is an overheated joint. It has a chalky, dull, or crystalline appearance and may show pitting on the surface. It's often the result of repeated efforts to repair a joint that won't wet properly due to contamination or lack of sufficient flux. A good way to inspect a joint is to roll it around under an overhead light. The movement directs the light on every spot and will quickly reveal any pits or discontinuities on the surface.